Ready. Ready. Ready.
Hello, welcome to Enlightning. I'm your host, Whitney Lee. I'm a CNCF ambassador and a developer advocate at VMware Tanzu. And I'm here with Marc, who's going to teach us about Kubernetes Dashboard. Marc, I don't think Marc can hear me. Or maybe Marc's frozen. Oh.
No, I'm not. Sorry. I thought we had a couple minutes before we went live. Sorry about that.
It's all right. Welcome, Marc. Tell us about yourself, please.
Thanks, Whitney, and thanks for having me. So my name is Marc Boorshtein. I'm the CTO of Tremolo Security. If you have spent much of any time in the Kubernetes world and you've had problems with like authenticating, you've been asking questions on Slack about that, we might have interacted. If you've read the Kubernetes authentication documentation and started using new and interesting cuss words, I'm the person to thank for that. I've been around in Kubernetes since 2015. Our company, Tremolo Security, has been really active, especially in the security space. I'm going to do a shameless plug. I'm also the co-author of Kubernetes, an Enterprise Guide, first edition, second edition, and third edition coming out, I want to say mid-September. I think that's what the latest release date is. So yeah.
Awesome.
And
so
that's me.
Those folks who watch this show regularly might be thinking, hey, we've been covering a lot of observability tools. What's this security guy? Why are we talking about security so much right now? And that is, I guess we're going to uncover that during the course of the episode. But we are going to talk about Kubernetes Dashboard, which is a way to observe what's going on in your Kubernetes cluster. And we'll be talking about that too, how to use it securely, right?
Exactly.
So let me remove our names. Also, let me say hi to Koramaju. Hello, Koramaju. Thanks for being here, friend. So glad you're here. Koramaju always contributes to the chat very thoughtfully. It's the best. Okay, our names are gone. It's time to get to business. So Koramaju says all the best for your third edition, Marc. That's nice.
Thank you, sir.
So let's talk about what problem is Kubernetes Dashboard solving. I think maybe with this tool more than others, we can guess the answer to that a little bit, but let's talk about what the world was like before Kubernetes had a dashboard.
So it's actually really hard for me to say because the dashboard existed when I first got involved with Kubernetes. I first got involved with Kubernetes with 1.3 when RBAC and OIDC were first introduced. And I will say that the first thing that I did as soon as I got my first cluster up and running was say, now what? Is there something I can go look at to see how do I poke around in here? So the first problem that the Kubernetes dashboard solves is just giving you kind of a visual roadmap of what a cluster even looks like. Like if you've never used Kubernetes before, right? What's a namespace versus a config map? Like how do those things kind of come together? Like
Mm-hmm.
what is that stuff? How do they relate to each other? And that's
Mm-hmm.
something that you need something visual to tell you, right? Like a way to give you a map. So that was the first thing that I saw when I first started using the dashboard.
Uh-huh.
Um, and then from kind of break it up into um, operations, support, and observability, right? So from a operations standpoint, the dashboard gives me the capability to see and interact with lots of information at the same time. So I'm debugging something, right? Something's gone wrong. I need to figure out what it is.
Uh-huh.
How can I know very quickly if my nodes are all online? I can do kube control get nodes and then look, maybe I'm a JSON wizard and I can pipe it into JQ and that'll format everything the way I want. But I can also log into the dashboard, click on the nodes and see, oh, look, half my nodes are in red status right
So we're talking about security, but also we're talking about like just navigating through the cluster to
now.
find problems. Yeah.
Yeah. I mean,
What do
it's
you?
just the
Uh-huh.
API can only give you so much information at once.
Mm-hmm.
And even if you're an expert at the API and you know intrinsically how all these things relate, just
Mm-hmm.
think about the amount of time of trying to go from, let's say you're debugging an ingress as an example.
Mm-hmm.
Okay. Your ingress controller is looking for an endpoint to see if that endpoint is, or an endpoint slice is available to see
Uh-huh.
if it's connecting to a service. So if your ingress, you go to this host and your ingress controller gives you back that can't be found message,
Uh-huh.
you can pop open kube control, say, okay, I'm gonna, kube control get ingress, kube control get end size, kube control get nodes, or
Uh-huh.
you can
Uh-huh.
log into the dashboard, click on the ingress, and it'll tell you immediately, I'm connected to this slice or this
Uh-huh.
endpoint, which is connected to the service, and it will very quickly tell you where that broken piece is.
Okay.
Um, so just the volume of information that you can consume is really fantastic
Yeah.
compared to just working with kube control or some other command line API tool. And
And
that's on the observability side. Go ahead. Sorry.
so even for a seasoned Kubernetes expert who really knows their way around kube control, who really has a great mental model of how everything's working together, is there still a case for Kubernetes dashboard, or is that
Oh, absolutely.
yeah, because of the
You
volume
know,
of the things you can see
the
at a glance. Yeah.
the volume, but also think about it this way. And there are two ways you can think about it. You can think about it this way as good or bad, depending on your perspective. But it's 2024.
Uh-huh.
We all have these things, right?
Uh-huh.
Imagine a world where you don't have to be sitting at your desk to interact with your cluster. You
Oh.
get an alert, you need to check something, you pop this thing open,
Uh-huh.
you securely log in using multi-factor authentication. This thing is big enough that, or on a tablet where you can
Uh-huh.
interact with the cluster, figure out what's going on, maybe even make a change, log out, and you're done. And you've never had to open up your laptop.
And you can do that with Kubernetes dashboard?
I do it all the time with customers that I help manage their implementation.
Cool.
So
When you when
it's
you said
it's one
it
of those things that when you use it, it can be really freeing from the tyranny of the keyboard.
yeah, the tyranny of the terminal specifically. Yeah. When you said it's 2024, I don't have to be at my desk to see the cluster. I'm not gonna lie, I pictured like VR glasses, like walking. Pause. Yeah. Anyway, so basically, it's good for learning how things work together. But even if you really know how things work together, it's really good to get volume. Like, what's the saying? Like a picture's worth 1,000 words. It's good to get
Exactly.
a quick, a big view really fast, have a deep understanding, and it's good for finding problems. So finding problems, understanding how things connect, and just understanding, like visual can provide more information, more high level
But
information at once.
much like a good infomercial, we're not done yet, right? Like there's still a lot of power there in managing operations and managing support. So, the greatest lie ever told in Kubernetes world is eventual consistency, right? Like, anyone who's ever had a crash loop back off knows that it's not actually eventually consistent. At some point, it says, no, we're going to stop. It doesn't always fix itself, even when that problem has to happen. So one of the most common things that I run into is people need a way to do something, large scale implementations will often need a way to allow somebody who is not a full SRE, somebody who might just be a member of an application support staff, to be able to view logs and delete a pod. Right? And you can do that with the dashboard fairly easily. And so it's something where now you can provide that mechanism without having to write something custom. Say, okay, I'm going to build in this custom thing that lets people, integrate with, lets people integrate with my cluster in these very specific way. No, I'm just going to enable RBAC in a way that says, okay, the user who's logged in can only do these certain things. And, it's not the most responsive UI. Like if you're used to something like OpenShift or even, I think Rancher will do this, where it's like really responsive, like, oh, RBAC says you can only look at these namespaces, so these are the only ones we're going to show you. Like it's not quite that fancy. I think Headlamp does that too. But the security side of it's there. So someone who tries to hit that button is going to get an error that says, no, you're not allowed to do this. So it really opens up the ability to simplify your support processes as well.
Cool. When you talked about an infomercial, like, well, we're not done yet. I was imagining like black and white video, someone typing cube control into the terminal and a record scratch, and then colors and rainbows in the Kubernetes dashboard. Barun's here. Hi, Barun. Hi, friend. Shameless flex. I like this. I ran SSH from my phone and used kubectl commands to fix things from a phone terminal. A dashboard would have been better. You're in our infomercial. You're recruited for the black.
I feel
and white
that pain.
part.
That hurts me right here. I feel that pain, Barun.
Okay, so we've kind of talked about the problem space or also the solution space, like what we have talked more about Kubernetes Dashboard specifically, but I don't like to make assumptions to say like what a dashboard is. So maybe we can say, what is Kubernetes Dashboard? Maybe we can get a definition on the board.
It is, I would call it a UI representation of the API.
Oh.
It is probably of all the dashboards, the closest to the raw APIs of any of the dashboards. That can be a good thing. That can be a bad thing, depending on your perspective. It's a good thing from like a learning standpoint, because if you're working with Kubernetes, you really do need to learn the APIs at some level. And so too much abstraction away from the APIs kind of hides that. And going back and forth, because, it's not unusual to use both tools at the same time, right? It's not unusual for me to have the dashboard open, but I'm using kube control because some things are just easier to do from the command line. So having it very close to the API is a benefit to that standpoint, a very close mirror of the API. It can be a little frustrating if you want to do things that are fancy, like say, limit the API, limit the views or stuff like that, that other dashboards provide a little more flexibility in. But, picking your poison, but, me personally, I like to be closer to the API, as close to the API as possible.
So Kubernetes Dashboard is a UI and visual representation of the Kubernetes API.
I think that's a good representation or a good definition. Yeah.
Cool. And then there's a trade-off between being closer to the APIs and being able to do more complex things.
Not so much more complex things, but have a more maybe intuitive UI. Being able to customize it for more intuitive workflows. So, like the scenario where I mentioned earlier that being able to just delete pods and view logs.
Mm-hmm.
It would be nice, like if you're in that scenario, to provide an interface that just lets you view the namespace or view the pod logs in the namespace and the events in the namespace, and have a little button for deleting, and then remove all the other stuff that wouldn't be necessary. That's a little harder to do. It's not totally impossible to do a lot of that, but it's a little harder to do with the Kubernetes dashboard compared to other dashboards.
I'm going to call that, we talked about the idea of an adaptive UI in the headlamp episode that we did recently. And so when you're talking about an example where if a user's not allowed to delete a resource, then the delete button's not even there. They don't even see it. That's not something Kubernetes Dashboard, that's something a more advanced dashboard does. Yeah.
Exactly.
Barun has a question. What kinds of steps and thoughts? Oh, I'm sorry, it's Kuramaju's question. What kind of steps and thoughts are involved to create a dashboard?
Really, like, I guess what a dashboard for what? Like, are you talking about a general cluster management dashboard? Are you talking about a more specific use case dashboard?
I think in that question is the answer. I think the first step is, who is your dashboard for? What is it meant to do? Those are the thoughts. And then once you understand your user, then you can decide what that user, the optimum interface for that user might be.
Yeah, I think that's a great point.
So the Kubernetes dashboard, the user is like a Kubernetes operator. It's not meant to be.
Could be an operator, could be a support user. It could be a developer, right? If your application team has a developer on it that is, focused on the Kubernetes side. There are definitely multiple personas as to, especially depending on how you do the security for the dashboard. There are definitely multiple personas of users.
Will you repeat them for me? Kubernetes developer, SRE.
So you might have a developer, somebody in ops, a SRE. You could have a support person, so somebody that might not be qualified as a full SRE, but isn't really on the app development team either.
Do they all interact with the dashboard in the same way? Like, do they all have the same views, or would they? Is it different?
I think ideally they would have different views, but because the Kubernetes dashboard is just a representation of the API, they all see the same thing. So, like, I've seen some interesting use cases where I've had folks say, well, can we do like a read-only dashboard? Because the executives and the managers want to be able to log in and just, they like their dashboard. At that point, I tell them just build a Splunk dashboard and make them happy. But there's some customization that you can do. You can do plugins, but it's what you see is what you get.
Lee Bennett's here to help out with our users. We have devs, SRE, app support, DevOps, service desk. Awesome. Thank you, Lee.
Yeah.
That's awesome. So it seems like it's simple, it's straightforward, and I like that about it. It is and if you want something more focused or more complex, those solutions are definitely out there. But if you just need a dashboard to have a visual representation of your Kubernetes cluster, then you got one, and it's part of. Is it in the Kubernetes release? Is it part of the? Who maintains it?
Yeah, it's real. It doesn't. it doesn't have the same release cadence,
Okay.
but it is part of the Kubernetes GitHub org.
Okay.
So it's part of Kubernetes.
If I install
It,
Kubernetes, do I have a dashboard out of the
no,
box? Okay.
no, you have to install it separately.
Okay.
One of the things that I would also point out that makes it very different from like Headlamp, although Headlamp can run this way as well, or like Octant, or a lot of the other local dashboards, is
Uh-huh.
it's centralized, right? You don't have
Uh-huh.
to run anything locally to access it. And so if you're thinking about an enterprise environment, that's a big win, because in order to get something distributed to enterprise users, it's got to go through this long process. It's got to be approved. It's got to be packaged. It's got to get pushed out. Um, a lot of enterprises are starting to push for the same level of isolation of access to Kubernetes APIs as like SSH. So I'm starting to see a lot of enterprises are like, yeah, we don't want you to have kube control on
Yeah.
your desktop anymore. We want you to log into a jump box to use that. And while I have very strong opinions as to the security value of jump boxes,
Uh-huh.
sometimes the compliance folks are like, sorry, we have no choice.
Yeah.
And so being able to run something that is centralized, where you don't have to distribute it, is a big plus as well.
So by centralized, you mean it's running somewhere else that everyone else can access that place, as opposed to running
Exactly.
like on your laptop or needing a client on your laptop to access.
Exactly.
Okay. Marino's here. Hello. And
Hey,
then
Marino.
Hey, friend. And then Lee has a very good question that I'd like to address. Can we see Kubernetes Dashboard? So this show, the whole thing is we don't do any demos or screen sharing. So we're going to talk about a visual thing for another hour and never show it to you. But that's just how the show goes. It's what it is. But you're welcome. Of course, if you Google it, you're going to see it pretty quickly. So you have the power in your fingertips. Space Boy's here. Hello, Space Boy. Welcome.
Howdy.
All right. So Kubernetes Dashboard is centralized, and what's the benefit of that?
You only have one place to go to access and manage it, right?
Okay.
So there's nothing to distribute. It's a web application. There's nothing to distribute. There's nothing that has to go through a packaging. When you upgrade your clusters and you need the new version of the dashboard, you upgrade it in one place. And it allows you to centralize the security as well. So it really provides a much simpler distribution model. Now, this creates security issues, because now you have to securely access that dashboard and then get from the dashboard to the API server, which is a whole other discussion. But it's not, so it's a different type of security than having to package something, but it's a security that you as the cluster owner can own. Whereas if you're distributing something, you've got to go through someone else's process to make that happen.
That makes sense. Does it run, I have a couple, does it do multi-cluster? And if it only does one cluster, is it running in the cluster it's also visualizing? Where does it run?
It only does one cluster.
Okay.
I really hope they don't add multi-cluster, because I find that multi-cluster management inside of a single dashboard is actually a little counterproductive in a lot of ways. But that's a whole other rant. And yes, it runs inside of your cluster.
Okay.
It doesn't technically have to. You could set it up so that it ran outside of the cluster. I don't really see a lot of benefit to doing it that way.
Well, the only benefit I can think of is that if something goes wrong that breaks Kubernetes Dashboard, then you can't see you can't use Kubernetes Dashboard to help you understand what's wrong. So if it's running outside of the cluster, at least you have it separate if your cluster is breaking. It runs in your cluster. Yeah, okay. And it only does one, and it manages one cluster at once,
Yeah.
or visualizes only one cluster. We have nice active chat today. Thank you. Epic Tralala's here. Hello. Barun's asking whether that centralization is a conscious decision for the listed reasons, or does Kubernetes Dashboard technically need more access, or can it run out of the cluster with kubeconfig? So we're just kind of talking about that. Yeah.
You can do it. I mean, so here's the thing, because it's very quick, and just to expound on that a little bit, we talked earlier about how the Kubernetes Dashboard is essentially just a visual representation of the API. It's just using the same API as kubecontrol. So it's not doing anything special. You can have a kubecontrol configuration that talks to a different API server. Where it gets a little interesting and where you would have to be really careful there is security. Because what you don't want to do, and this is where people really get tripped up about the Kubernetes dashboard, is you don't want to be in a scenario where the dashboard itself has privilege. You want to make sure that the dashboard works in the context of the user, the same way kubecontrol does, right? Hopefully you're not distributing certificates for kubecontrol, because that's bad, and we don't want to do certificates for kubecontrol. You want to have a representation of you, right? I'm Marc Boorshtein. Marc has these rights inside of the cluster based on some kind of RBAC, right? And hopefully you're linking to groups inside of an external identity provider rather than large lists of RBAC bindings. But wait, we can, that's a whole other conversation. But the point is that when you use kubecontrol, you need to be running as you, right? To make sure that your security is applied. And that's where things get really interesting with the dashboard is, okay, how do we tell the dashboard it's Whitney, right? And then how does the dashboard tell Kubernetes it's Whitney? And that would be, that's where things really get interesting when it comes to the Kubernetes dashboard. And that's where people tend to get hung up, where they'll say, oh, the dashboard is insecure. So I think it was 2018, there was a breach of Tesla where someone deployed the Kubernetes dashboard with administrative privileges, put no security on it. And so somebody was able to get into privileged pods through an unsecured dashboard, get cloud credentials, and start spinning up stuff in Tesla's AWS environment. So the security aspect is really where people get hung up. And it's not that can't be secured properly. It's that most people just do it really wrong. And unfortunately, the default implementation that the documentation uses is almost as wrong as it can get.
So,
but it does that for a reason.
Okay, I want to hear that reason. I wanted to talk about these comments, and then I kind of have a question about where we're going, just so I could set up the board. So the dashboard is a collection of kubectl commands. Could you it'd be nice if it showed you the commands being run. Is that,
that would be it's not that it's a collection of control commands. It's that it's using the same API. Kubecontrol is just a CLI interface to the API.
Yeah.
Right? There's nothing kubecontrol does that isn't already exposed through the Kubernetes APIs. So whereas kubecontrol is, using Go SDK to talk to the API. Dashboard also uses client Go SDK, but the point is that instead of it being a CLI interface, it's a, it's a web interface. But yeah, that actually would be a really cool feature to have actual kube control commands.
Yeah. So Kubernetes is you use a kube API to manipulate your Kubernetes, and then kubectl works through kube API, and dashboard is another interface through kube API. So it's not like dashboard into kubectl into kube API. It's dashboard is just its whole other thing. I do a picture because sometimes a picture is helpful. I can't show you the dashboard itself, but I'll draw you a picture, Lee. All right. So when we're okay. So the dashboard and security is an issue. And so one thing you just mentioned is identity. Like, because identity wasn't managed well in a particular installation, someone was able to get in and break it out. So I guess my question is, if we're going to dig into security, which I'm totally fine with, first of all, do you have any? And I think the fact that this is just a visualization of Kube API answers this question, but I'm going to ask it anyway. Can I see anything related to historical data or trends over time or anything like that about behavior? No.
Not that isn't available directly through the API. So, like, as an example, if you have metrics installed, it'll query the metrics API, and you can get a little bit of trend data, but it's not like having the prompt stack deployed. So you can get a little bit of history. But it's like, so as an example, let's say you have a cron job, and that cron job, runs once a day. Kubernetes keeps the job definition in the pod for, I think, 3 iterations of a cron job. So you'll see that in your, when you look in the dashboard for the namespace. But it doesn't have its own internal data store to collect information the way Prometheus or Grafana do, or other observability tools do. It's really meant more for point in time.
So it's, but not much. No internal. Where the metric server just stores it in memory. No internal storage. So, like you said, if something's breaking, like, we can use Kubernetes Dashboard to see how different components are interacting with each other right now. And maybe that will help debug. Maybe that'll help you learn what's happening. There's a lot of use for that. But in terms of more traditional observability, how things are happening over time, looking at trends, looking at performance, this is not for that.
Yeah, you're not going to. Yeah, you're not going to replace a good traceability tool with the Kubernetes dashboard. Okay.
And that way, I could kind of infer that from the definition of the dashboard, but it was nice to talk it out. And so I think I'm done thinking about the observability piece, and I'm ready to move into the security piece. And what I want from you to help me structure the board is, like, I know identity is a problem already. Is identity the problem, or are there a few different problems that that don't need to be? Yeah.
Yeah, I mean, I would say identity is probably the biggest problem. That is usually the biggest roadblock to getting the Kubernetes dashboard deployed, and doing it securely.
So before we dig into identity, I would like to understand your statement, your provocative statement you made earlier about how the way that the Kubernetes dashboard installation is in the docs is the worst way to install Kubernetes dashboard, you said. I would like to hear about that. Yeah.
So, a very short primer on Kubernetes identity for folks that are new to Kubernetes identity. Yeah. Just like in the Matrix, there is no spoon. There are no users in Kubernetes, right?
Okay.
There's no object called a user. There is no object called a group, even though inside of RBAC you reference users and groups. And you have to assert that identity from some outside source.
Uh-huh.
So The most common way people have to do that is via certificate. That's the first way, right? You get your cluster up and running. You have this master certificate, bypasses RBAC. It lets you do everything. But that identity is not from Kubernetes. That identity is derived from the fact that that certificate was signed by a CA managed on your cluster. The better way to do it is to use some kind of external identity provider. So maybe your Active Directory, Okta, GitHub, whatever, right? Like whatever your enterprise environment has as an option, where you can say, okay, Whitney, this is Whitney's identity. She has to use multi-factor authentication. Here are the teams or groups that you're a member of. And I can revoke this at any time. And you generate a token. And that token is what's called a JSON web token. It's a little bit of JSON that says who you are, when it was created, how long the identity is good for, what groups you're a member of, and it's digitally signed. So that way it can be passed around to different systems. The downside, or if you're talking about a managed environment like EKS from Amazon or AKS from Microsoft or GKE, right? They have their own cloud IAM that you get integrated with. But then the question becomes, okay, do the people who manage the cloud also manage the identity? And that's a much deeper topic. The point is that there are different ways to do this. So
and
when
Spiffy.
Oh, go ahead. And Spiffy? So Spiffy are tokens. Like Spiffy is workload identity, not so much user identity. You could use it for user identity, but it's really meant for workload identity. It's a little bit different.
Okay, so we're specifically talking about human users right now.
Exactly.
Okay, certificate based. Okay, so basically users need some way to have identity in the cluster, and Kubernetes doesn't do identity natively. Like there's no object called user. You can and so that identity can come either from a certificate authority that might be internal to your company, it might be running in your cluster, or that way the user is going to get a certificate, or it could also come from external providers.
The certificate has to come, as of right now, there's been talk of expanding this, but as of today, the only certificates that Kubernetes will recognize are certificates issued by the Kubernetes CA. So if you're so like US federal users, as an example, all have what are called PIV cards. They're these smart cards that you use for certificate authentication. You can't use that to authenticate to Kubernetes because those certificates are not issued by a cluster CA.
Okay.
You would have to you would have to authenticate, get a JWT, and then use that JWT instead to make your API call.
And the JWT is JSON web token.
Web token.
So that's the token-based way. Yeah. Okay.
Right. So there is a kind of an exception to the Kubernetes doesn't have users statement in service accounts.
Yeah, that's what I was.
But a service account is not a user. A service account, when Kubernetes was first created, the point of service account was to provide identity to workloads, not identity to users. But because all the stuff that you put in your notes is kind of complicated and requires a level of knowledge that a lot of folks getting started with Kubernetes don't have, it's just a whole lot easier to create a service account and hand it out. And so what has happened, and this is where we get to the reason why the documentation, I think, the documentation is the wrong way to deploy it, is the documentation says, okay, you're going to use the dashboard. I'm not going to make you set up all the stuff you need to do to make this work securely. I'm going to get you to the point where you can just log in.
Okay.
And so that's what the documentation does. It says, okay, go generate a service account with the RBAC of what you want, get the token, and then when you go to the dashboard, it's going to ask you, hey, give me a token, and it's just going to use that token. The reason why you don't want to do that is a few reasons. One, service account tokens were never meant to be used from outside the cluster. It's an anti-pattern.
Okay.
So you're using a tool in a way that might work, but it's not the way it's meant to, and you're going to run into a lot of unintended consequences. So that's one. Two, you need to securely get that token to someone, right? So like if I'm going to grant you access via the dashboard, am I going to email you that token? Am I going to tweet that token? Am I going to put it, am I going to put it in a form? Like what?
Yeah.
And then once you have that token, how do I know that you're not checking it into a Git repo somewhere? Right? Or sharing it as a file. I mean, probably half a dozen, maybe a dozen times a year, there's somebody who comes into the SIG off on the Kubernetes Slack channel, be like, hey, I accidentally shared our master config with somebody who shouldn't have it. Can I revoke that? And the answer is sorry. No, you have to regenerate keys for your entire cluster. So, what you want to do is you want to minimize the likelihood that that token is going to get abused. And so the correct way to deploy the dashboard is you put a reverse proxy in front of the dashboard. And then that reverse proxy becomes responsible for authentication and session management.
Okay. Solution, I'm going to say, over best practice. We have a question. How does the Kubernetes dashboard relate to the Rancher dashboard?
So Rancher provides its own kind of holistic approach to managing clusters. If you're using the Rancher dashboard or Rancher in general, you probably wouldn't need the Kubernetes dashboard because Rancher has all those functions. It's got ways of doing the API with user context. So if you're using Rancher, I would probably focus more on, if there are use cases for providing user developer access to the cluster, I would focus more on how you do that with Rancher rather than trying to set up the dashboard on its own.
Great answer. Thank you for your question, Jafar, and thank you for being here. So we have a reverse proxy outside of our cluster that's giving the user identity, and then that user uses that identity. Is that reverse proxy giving authorization? Like it is giving authorization, but is it also controlling access levels?
It could.
Related to the
degree.
Dashboard?
Yeah, I mean, once you have that reverse proxy in place, you can, having that reverse proxy in place lets you do a couple of things. One, it gives you session management. The Kubernetes Dashboard session management is it generates a random key. You upload your JWT to it on login. It encrypts it and stores it in a cookie. That's not session management, right? Like that's not protection against, that's not protection against, cross-site scripting. That's not protection against session retries, cookie hijacking, things like that. And session management's hard. Like that's one of the hardest problems to solve in web identity is how do you do effective session management? So putting the reverse proxy in front allows you to do session management, one. Two, it allows you to do shorter lived tokens. So I wrote a blog article, I think it was almost 2 years ago now, comparing the different common authentication approaches for Kubernetes. And one of the things I did was I said, okay, how would we do this with the dashboard as well? And how would we secure that? And yep, that's the link. And so we go into the nitty gritty of how that works for Open Unison, Keycloak, Pinniped, and Dex.
Cool.
And so one of the things that we said was our reverse proxy should be doing, short-lived tokens. Because, we talked about a problem with the service account tokens was what if you checked it into Git by accident? That same problem exists if you're talking about, external token. You get a token from Dex or you get a token from Open Unison that's good for 3 weeks. That's every bit as dangerous, right? Like that's no less dangerous. So what you want to be able to do is you want to have a reverse proxy that knows not just how to authenticate you and get your token, but also how to keep that token fresh so you can be constantly refreshing it. The other thing that the proxy model gives you is the concept of impersonation. So we've been talking, not replay attacks. Impersonation in this instance means, think about an EKS cluster, an AKS, any kind of managed environment where your cloud IAM is what controls access. That means that the people who control the cloud are now in control of who has access to the cluster. And from a technology standpoint, that might not be a big deal. From a managerial and a silo standpoint, that might be an issue because they say, hey, look, we got enough problems. We don't want to be dealing with who has access to your cluster. That's a you problem. That's not a me problem. And so they'll say, go to the centralized identity service to do the authorization and to manage your authorizations, your RBAC bindings. Well, if you want to not use your cloud IAM, you can generally not use OpenID Connect the way you could with an on-prem cluster because you don't have access to those configuration parameters inside the cluster. So the concept of impersonation exists to say, okay, I'm going to let a reverse proxy authenticate you. So this reverse proxy has authenticated you as Whitney. You put in your MFA. It knows who you are, and it's sure about that. So instead of sending your token down to the API server, which won't be able to do anything with it because it can't talk to your identity provider to validate it, it's going to say, I'm going to send my own identity with a bunch of headers that says, don't use my identity for RBAC, use Whitney. And here are Whitney's user, here's Whitney's group. So if you've ever used kube control -- as to debug RBAC, that's impersonation. You're not using it for authentication, you're using it for testing, but that's impersonation. So that gives you the ability to deploy the dashboard securely, both on-prem and in a cloud-managed instance.
So in this case, impersonation is a good thing.
Yes, in this case, impersonation is a good thing, assuming you do it securely. So you want to make sure that now that, because the way Kubernetes does this is based on RBAC, so you've got to provide the identity with the rights to do impersonation, which means now that impersonating account is a privileged account. So you want to be really careful to make sure that you've locked that account down. You're locking down access to the namespace. You're making sure that the only network connections that are coming in through your ingress. So there's a lot of things that you want to do to secure that. But once you've done that, I mean, those are all built-in things to Kubernetes. That's not anything special. You now have the ability to securely deploy the dashboard without having to give people service accounts.
Is it for air-gapped only? Or is it more, to communicate access levels without service accounts?
Yeah, it's more to avoid service accounts or cloud IAM to be able to access the dashboard. So being able to externalize your authentication without having your cloud team be in the middle.
And we're saying to install the dashboard, but really this is not really about the dashboard, to do anything with privilege, to view the dashboard.
I mean, it's from the dashboard's perspective, because what you want to do is you want to avoid giving the dashboard itself any privilege. So when you deploy the dashboard out of the box, from an RBAC perspective, it's got very, very tight RBAC privileges. Like, it can read a couple of things inside the cluster, it can scrape metrics, but that's it. So if somebody gets control of the service account for the dashboard, they can't use it to abuse the rest of the cluster. Instead, what you want to be doing is you want to be in a scenario where your dashboard is leveraging the identity of you as the user to perform actions on your behalf. So that way, it's a lot less likely to get compromised.
That makes sense. So I have an unrelated question, but if we have more to say about this, I'll save it.
No, go for it.
My unrelated question, we've been talking about Kubernetes Dashboard and a Kubernetes cluster. What happens when you install all kinds of tools into your Kubernetes cluster, all the different tools that rely on the Kube API and teaching it new custom resources? Are those also just as visible in the connections between them, just as visible in the Kubernetes dashboard?
Yes, and because Kubernetes Dashboard knows how to do CRDs, it doesn't necessarily know what the relationships between the CRDs are. But if you figure out how to securely deploy the Kubernetes dashboard, deploying all those other tools becomes a lot easier. So I'll give you an example. VMware makes a really cool tool, applications dashboard, VMware apps, I think it's called. It's a Helm dashboard. So it's a UI for your Helm charts and what's deployed, and it's a really nifty tool. And what you deploy it the same way because it has the exact same problems. It talks to the API server on your behalf. You don't want to give this tool the ability to be privileged if you don't have it properly locked down. So you end up having to solve that same problem. If you're using Istio, the Istio service mesh, it has a UI called Hiali. Exact same set of problems. You need to be able to interact with the Kubernetes API on the user's behalf, and you don't want to give it privilege. So the Tecton has a dashboard. Again, exact same problem. You need to be able to provide that identity access securely. You're going to do it the exact same way as you do with the Kubernetes dashboard. I'm trying to think of Argo does not do that. Argo does have its own. It already has cluster admin access. There are commercial tools out there that interact with the API server. So there are debugging tools that need to interact with the API server. They will also, need to be able to interact this way. So once you've figured out how to securely deploy the Kubernetes dashboard, it actually makes it a lot easier to securely deploy a lot of other cluster management.
Okay, let me repeat. So I understand I have a Kubernetes cluster. And that Kubernetes cluster has a Kube API server. That's how we're accessing information from inside of it.
Yep.
And then the Kube API is interacting with the dashboard.
Yep.
And that's how we're able to view everything we want to know, which is great. And so now the problem is if you give dashboard privilege to interact with the Kube API, that's dangerous. You're increasing the threat boundary of your cluster. There are more ways now for people to be able to access it. And so the solution to that is to run a whole different machine in between the dashboard and the Kube API. And it's this
No,
reverse proxy. No.
that
Outside.
box actually goes on top of the dashboard. So the dashboard talks directly to the API server.
Okay.
But the user interacts with the reverse proxy, which in turn interacts with the dashboard on the user's behalf.
Okay. So I'm glad we're having this conversation. Barun has a question. And that is, why do we say that service accounts are not meant to be used outside of the cluster? My understanding is that access control kubeconfig by associating it to a service account token.
Because that's not what it was designed to do. The point of service accounts was to provide workload identity. If you're embedding a service account token into a kube control configuration, you're now in a scenario where you've got a JWT that you can no longer control out there in the wild. You need to, there's the question of distribution. How do I get you that JWT securely? How do I revoke it? Short answer is you have to delete the service account and recreate it, or it's a very long, if it's a 124, Kubernetes 124, the default started to be bound token projection. So the tokens expire, but they expire in a long, long time. So the point of those tokens is to provide workload identity to your pods so that your pods can interact with the API server securely. They are not meant for humans. They were never meant to be used from outside the cluster. People did that, what you're talking about, Barun, of handing out service account tokens, because in order to do it right, that means you need to be able to integrate it with an identity provider. You need to manage short-lived tokens. You need to have all those controls in place. And that often means relying upon outside teams. So if you're talking about a common enterprise where everything is siloed, right? In DevOps, we like to talk about breaking down the silo walls. Well, that's just not the way most enterprises work. Enterprises are managed by silos. So the people who own identity, whether it's AD, Okta, even GitHub, they're not the same people who own your cluster. So if you have to go to them to do the integration, that's going to slow your velocity down. So you're just going to use the tools that are there. So even though, yes, you can drive in a nail with a screwdriver if you work really hard and are kind of careful, chances are you're going to hurt yourself. And that's what we've found over the course of the last 10 years is people hand out these service account tokens. They get checked into Git. They get handed off to someone. They get accidentally emailed. They get leaked, right? Like, there's a bug in something and it gets leaked out. So these tokens, they're not designed to be used by humans. It's a complete anti-pattern.
So my question from that is, surely when Kubernetes was created, the creators had some sort of plan for how humans should authenticate to the cluster. Is that what the certificate-based version is? Or like what was, or has it always been, you've always been meant to put reverse proxy in front of it? Like what?
So the first point is, one of the things that made Kubernetes so successful was they didn't try to solve everything at first.
Yeah.
They knew there were problems that they were going to try to solve down the road, and they wanted to be in a scenario where they could solve that problem. When version 1 came out, they didn't necessarily want it to be a ready-to-go system, but they wanted to be in a situation where they can add that functionality down the road. They did a really, really great job of that.
Mm-hmm.
So from an authentication standpoint, the very first implementation, you had service accounts, you had certificates, and then you also had this thing called ABAC. And so in the first versions of Kubernetes, you would create a file, CSV file, comma separated file that had a username, a token, and some permission. And your API server would read from that. The problem with that approach is that it's a static file. You had to distribute it to each API server.
Same problem
and
as service accounts.
yeah. Well, so it was actually worse because you also had to update. You had to restart the API server on every update.
Yeah.
So it was a stopgap. It was never meant to be the long term. And then certificates came out. Certificates were very common. But the problem with certificates is, one, Kubernetes has no concept of revocation. So if I issue you a certificate, that certificate's usually good for a long time. Like it could be a year, it could be 5 years, depending on the policies. Well, Kubernetes also embed, what if you leave your job? What if your role changes? Right? 5 years is a long time, especially in this business, right? So you want to be able to say, okay, this certificate is no longer good. Please don't use it. That's called revocation management. Kubernetes doesn't support that. It's been a constant finding since Kubernetes has been doing security audits. It has an independent audit. The project has an independent auditor that comes in to audit the code. And they've had this constant finding of certificates are insecure because they don't handle revocation. And they're probably never going to handle revocation for a lot of reasons. So you had that, but that's not really a great solution. Then with 1.3, OpenID Connect came on the scene. And that was really the first time where you could open up Kubernetes securely in a way that would reflect modern security requirements. Because now you don't have to give out a service account token. You can rely on this external identity provider that has, thousands upon thousands of hours of review time in the protocol to be able to lock down that approach. Now, when you start talking about cloud IAM, it's a little bit different because there's a lot of different solutions. So like AWS is an example, uses a kube control plugin that allows you to use your IAM credential securely via like a little mini reverse proxy that uses certificate authentication. But that's not available to you in the dashboard.
So,
right? Because that's just for the CLI.
So I'm a user and I want to see my Kubernetes cluster. I'm there. Oh, I messed that up. And so I'm going to log into the reverse proxy somehow. And so now the reverse proxy, can it have all the same ID systems as, can I use GitHub, LDAP, Okta, whatever for here?
Depends. So there are two ways you could do it. There are basically two ways you could do it.
Yeah.
Option one, and we go through these in the blog post that you put up earlier.
Okay.
Option one is you stand up an identity provider like Keycloak, Dex, or Pinniped, and then you use a tool like OAuth 2 Proxy. Now, OAuth 2 Proxy knows how to establish a trust with your identity provider. It knows how to keep the session updated. It has its own session management built in. And it knows how to, once you're authenticated, take that token and then put it into each request that goes down to the dashboard.
Okay.
But that all requires manual integration.
Okay.
Or, shameless self-promotion here, you use Open Unison. And Open Unison combines all that into one thing that says, okay, no, we're going to do all this for you and you don't have to think about it.
Okay.
And then if you're going to do it in the cloud, you have, again, you have two options. you can do what I just described, plus add a tool like KubeIDC proxy that knows how to take that token and translate it into impersonation. So you have two reverse proxies to make it work. Or again, OpenUnison knows how to do all that natively.
Okay.
And this is why people like service accounts, because everything I just described, it ain't rocket science, but it requires a level of knowledge and understanding to do. And, especially if you're an enterprise, OpenUnison is the only one of those tools that you can buy a commercial contract for. Like, you can't buy a commercial contract for Dex. If you're a Red Hat customer, you can use Red Hat SSO, but you can't buy a commercial contract for Keycloak. There's no commercial contract for OAuth 2 proxy. So, if you're in a regulated environment that says you need to have a support contract in place, those tools aren't going to do it. You've got to use something that, that has commercial support. So that's also a big distinction. It's not just making the technology easy, but it's also making the compliance easy that you have to think about.
Yeah. We have a general Kubernetes security question. I think it's related to security. It's not too close to what we're talking about, but I think I would like to address it. Do you recommend splitting dev, test, prod Kubernetes environments like into different clusters or into different namespaces? How do you do RBAC so that devs can't deploy to production?
So that's a great question. So I kind of take it from two different angles. One, absolutely different environments for dev, test, prod. You want to separate out for a couple of reasons. One, if your devs deploy something that is development into a production cluster, and the bad thing happens, and the bad thing will happen because bad thing always happens at some point, right? Like, we don't have jokes about senior devs being like, "Oh, you're not a real senior developer unless you've crashed the entire environment by deleting the database for no reason." It's because that happens on a pretty consistent, basis. We've all done.
Yeah.
So you want to limit the blast radius. So that's one reason. But the other reason that you want to make sure to have multiple clusters per environment is you, as the cluster team, need to be able to test out processes without impacting your users.
Yeah.
Because a development cluster might be development to the application team, but it's production for you. Because
so if
development goes down, developers are like, I can't do my work.
Yeah.
So even though it's not customer facing to their standpoint, it's customer facing to your standpoint.
Right.
So you absolutely want to have different clusters for that.
Yeah. Developers might want to try out new Kubernetes tools, and they'll want to install those into the cluster, and some of them might take root access, and and in general, any experimental behavior just is much less palatable if it's running alongside production workloads.
Well, even like an upgrade, right? Like, if you're upgrading a cluster, there's the school of thought you should never upgrade a cluster. You should always, build a new one. But even in that scenario, if you're going to upgrade a cluster, you're either going to build a new one and move everything over, or you're going to go do an in-place upgrade. Either one, you as the Kubernetes team want to make sure you can test that without overly impacting your users. So you definitely, and I'm a huge proponent of multi-tenancy, but not at the environment level. Environments should be split out into their own clusters. And then as for, managing who has access to the environment and prod, I have a little bit of a contrarian opinion on this. Most of my security brethren will say developers should never have access to production. I don't think that's reasonable. I don't think that's realistic. especially in a world of monoliths. It might work better with microservices, but with monoliths, that's a lot harder to do. Because think about it, there's an outage of your application, right? You're called into the CIO's office to explain it. I don't know. I couldn't access it because they don't let the devs access production or make changes to production, right? So it becomes a brainstorming game, which again, we like to pretend doesn't exist in the DevOps world because we're all friends and we all think about we all hug each other. But in reality, that's what happens, right? We start playing brainstorming games. And so not being able to provide your users with the access that they need becomes counterproductive. And if you think about it like a pendulum swinging back and forth, if you have if you have it to the far one extreme where it's like I'm going to completely limit access, what ends up happening is the team that manages that access gets burned so many times, they say, oh, forget it. I'm just giving you this blank slate. You're now responsible for security.
Yeah.
And so you're supposed to put those rules in place, but application teams are not security experts. So this pendulum goes back and forth. So if you securely provide access to the production environment under the correct circumstances, you're going to get a much more secure approach. And so, like Lee's bringing up, PCI security, saying that PCI security says that it can't. I would say that that's not entirely true. You need to be able to limit when it happens. You need to be able to audit it. So you have things like privileged access management that says, and I'm doing this with a customer right now, that says, you know what? Admins can't get access to the system unless it's tied to an incident that's been approved by the change board, right? They're devs, but they have access, but only with associated change board approval. So that's the process that you put in place. So it's a whole other side of talking about, but I would definitely say, the hard and fast rule, you don't give devs that. It's not that you don't give devs access. It's that most implementations are not mature enough to be able to do it securely. And that's why they say, I don't want to give devs access.
I'm going to bring it back to Kubernetes Dashboard. Is there anything else we should know about Kubernetes Dashboard? I guess period, but also from a security standpoint. We have this much space.
I mean, I think the really key thing to understand about Kubernetes Dashboard security is Kubernetes Dashboard security is Kubernetes security.
Okay, yeah,
right?
That makes sense.
Because
I was picking up on that.
It's the API.
Yeah. I'll write that down. I like that. And that's our final thought, more or less. If anyone has questions, please do ask them now. Is Kubernetes security? In the end, it is securing the Kube API.
Yep.
And so Kubernetes, now, do other dashboards that have more layers in between the user access and getting at the Kubernetes APIs, do they still have these concerns? Or is it just their problem to address them?
So, like, if you're talking about, like, Headlamp is a great example. Yeah. When you run Headlamp locally in your environment, it's just using your kube control configuration. So if you're logged in to your cluster using an external OIDC provider like Dex or OpenUnison or whatever, Headlamp is just piggybacking off of it. It uses the same client Go SDK that kube control does. So while kube control is constantly refreshing your token, so Headlamp. So you don't have that separation between your kube control configuration and the API the way that the dashboard does, because the dashboard runs centrally.
Yeah.
The other thing, the other kind of dashboard, so things like Kiali and Tecton, where there's more specialized dashboards for specific APIs, those will absolutely, those will be easier to deploy once you figure out how to deploy Kubernetes Dashboard this way, because they use the same concepts to be able to interact with. And so you're actually able to you're able to more quickly build clusters that are more responsive to users. So instead of having to rebuild, like KubeApps is a great example. That's a great little package that all it does is Helm, but I mean, that's huge, right? Being able to just see, oh, these are the Helm charts that are deployed into my cluster, and these are the values, and like all this stuff. That's huge. Why would you want to rebuild that on your own for some specialized use case when you could just use that? So it teaches you how to do that as well.
I talk to a lot of CNCF tools, a lot of built on Kubernetes, and some of them do require identity to be able to do their thing, whatever it is. And a lot of times, like they literally just say, they just get the identity from wherever. Like it's not, like that's not the part of the problem they're solving. So
you don't want that to be the part of the problem they're solving, right?
Exactly,
like that, and that's the great thing about the way that the dashboard is set up, is it says, look, this ain't our problem. This is your problem. Solve it the way you need to. And it was a really smart design choice, both on Kubernetes' part and on the dashboard's part, to try not to tackle this on their own.
I agree. Yeah. So it's extensible, and as technology gets better, Kubernetes itself gets better. That's awesome.
Yep.
I think that's a wrap. Is there anything you'd like to I'm going to do a recap, but is there anything you'd like to say in conclusion before I recap everything you've taught to me today?
I probably have said enough.
All right. So basically with Kubernetes Dashboard, so you install a Kubernetes cluster and you're like, yes, I did it. Now what? And then you're like, how can I see what's happening? You of course can use kubectl, but as kube control, but as a user, you may want other ways to look at it too. So a visual cluster view helps users understand how Kubernetes components relate. It's good for beginners, especially if they don't have a good mental model yet, but it's also really good for experts because a picture's worth 1,000 words sometimes to really quickly see a status on something. So the dashboard's good for navigating a cluster to find and fix problems in the short term. There's no storage as part of it. So there's a little bit of trend data that's available in memory that can be pulled if the metric server's installed, but there's not much, or whatever would be an etcd, of course, but then there's not much in terms of storage of historical data. It also, I said that already. So Kubernetes Dashboard itself, it's a UI, and it's a visual representation of the Kubernetes APIs. So it's very close to the Kubernetes APIs. So this has advantages and disadvantages. So it can't do some more advanced things. There's no extra processing between the Kube API and you. So it can't do advanced things. One example we gave was like have an adaptive UI where if you're not allowed to delete, there's no delete button. It does not do that because that would be more processing that happens in between the UIs and you, and that doesn't exist. So there's no layer of extra processing that other dashboards have. People who would use the Kube API is really anyone who would use a Kubernetes cluster. So we talked about DevOps people, Kubernetes developers, SREs, support staff, but they all see the same view. It's not custom views depending on use case. Again, just the Kube API. It's centralized because it's the Kube API, which is nice. Like it's easier to use. There's nothing to package or distribute or configure. Like it's all it's upgraded in only one place with your cluster, and the security then is centralized too. The dashboard usually runs as part of a cluster. That's the most common way to run it, although it's possible to run it outside of the cluster. And it does visualize only one cluster at a time. It's not for multi-tenancy. And then as you add custom resources to your cluster, you're extending the Kubernetes API to understand and work with those resources. And so therefore, that's also going to be visualized as part of your Kubernetes dashboard. So you can see your custom resources that you're adding to Kubernetes. So in the end, over and over again, lots of different ways that we're saying dashboard is a way to visualize kube APIs, and there's nothing in it, no more, no less. If you could do it, if you could figure it out by using kubectl, then you could view it in the Kubernetes dashboard, and if not, you probably can't. So then one thing about the dashboard is that if it's not installed correctly, it can be dangerous to use because you are giving this tool direct access to your Kubernetes API and your cluster. So that's something we need to be careful about. So to talk about that problem more, we talked about just the problem of identity in Kubernetes generally, human identity in Kubernetes generally. And so there's not like a Kubernetes object for a human user. We have a service account that's designed for machine, for workloads, to give identity to workloads, but that's not designed to give identity to humans. So human identity is understood by Kubernetes right now in a couple of ways. It can come from a certificate authority that runs as a part of that particular Kubernetes cluster. So you could do identity in a certificate-based way, but right now Kubernetes only recognizes its own cluster certificate authority for that. Or you can also get identity from external identity providers like Okta, GitHub, LDAP, etc., and then you get a token that can be used as identity. But if you are using service accounts for human identity, that's not the best thing. They're not designed for human workloads. If they find their way outside the cluster, that's dangerous. They can be checked in to get repos or otherwise leaked and shared by accident, of course. And then if that happens, they can't be easily revoked either. So the solution for the problem of identity for the user of dashboard to make it safe is to add a reverse proxy for identification. So you, as a user, you get to the reverse proxy, and the reverse proxy handles identity. And you can do that with DEX or Keycloak or Open Unison. And then if Open Unison is more of a full solution, but if you're using DEX or Keycloak, then that would embed it into the request into the dashboard, into the request to the dashboard. That token is embedded.
Right. You would need to use something else with that. So OAuth 2 proxy is the more common standalone proxy for that.
Okay. So OIDC up here, OAuth 2 proxy here. But there are more, I just wrote over my face. There are more benefits to doing it this way. So with this way, you can also do session management, which is a difficult problem in Kubernetes. You can use tokens that have a shorter lifespan, which are safer and are less subject to replay attacks. You can use impersonation in a good way to communicate access levels for a dashboard to what users should be able to access. And all of these are avoiding giving the dashboard itself too much privilege. And that's important. So basically, dashboard or any tool, you basically don't want to give any tool privilege to interact with Kube API itself on your behalf. Like that's just an unsafe practice. And so this is a way to avoid it with dashboard and with any tool, which leads me great to the last statement. Kubernetes dashboard security is Kubernetes security. It's all about securing your Kube API. And I think it's a recap of our conversation. Is there anything I missed or didn't get right?
No, I think that's a pretty great recap.
Awesome. It's been a lot of fun to make this resource with you. Thank you so much for sharing your time and expertise today.
Oh, thanks so much for having me.
Huzzah! This has been fun. So I'm going to restart the music and say thank you to everybody. There it is. So we had like a super awesome fun chat today. So thanks everyone for coming and chatting and participating. Thanks, Marc, for sharing your time and expertise. Yeah, and thanks everyone who watched the recording. I appreciate you. Bye!